Hello, friend. I'm good.
Where have you been for the last 30, 40 minutes?
Oh, actually, I was on AWS On Air. So that is the AWS On Air Twitch channel, which is streaming in a similar way to this, but all about various kind of things on AWS. And I was demoing Lambda scaling.
Lambda scaling. What's happened in Lambda scaling recently then?
Well, it's funny because Lambda's always scaled really, really well.
Yeah.
And people sometimes scratching their head going, that's one of the things you don't need to improve. But come on, we always want to improve kind of things. So previously, Lambda used to scale by 3,000 concurrent invokes as a burst, and then 500 every minute. So if you needed 10,000 concurrent Lambda functions, which means sort of 10,000 parallel requests against your API or something, it would take 12 minutes to get there. We decided now we can do better than that. So, and that was also shared between every function in your account.
Okay, hang on.
Yeah.
Slow down. Let's go back.
Yeah, let's go back. I've just been doing the whole demo, so I'm like, it's all in my brain.
You've just been doing a deep dive demo, but let's start from the beginning for people that perhaps are not super familiar building with Lambda. What do you mean when you say Lambda can scale for, what did you say, 3,000 concurrent executions? Oh, hello.
we've got
So what does it mean that Lambda can scale for X amount of concurrent executions?
So the way Lambda works is when Lambda is always triggered by an event. Right. So something kicks off a Lambda function for it to run. And this can be anything. This could be an SDK call. It could be behind an API. So literally every HTTP request against something like by API gateway, for example, is going to instantiate an instance of a Lambda function. Right. This is a little micro VM that spins up in milliseconds, is really fast to run, and then is then going to process your code.
Runs your code in response to an event.
And that's behind an API. It can be changed to a database. It's going to kick off an event as well. Lambda integrates with, I've actually forgotten how many services. I think it's 100. I'll make up a number and get it wrong. But so many different services that a Lambda function is then going to kick off.
So that's what it means to invoke or run a Lambda function.
That's one.
That's one invocation of one Lambda function.
Now, obviously, if you're running a successful website, you hope you're not getting one request at a time.
Yes.
You would maybe want a few more requests at a time.
Sure.
So the way Lambda works is it can only handle one request at a time. And so if an additional request comes in while Lambda is doing something else, it needs to spin up another execution environment, which also takes milliseconds to spin up, and that keeps going. So if you've got literally 1,000 requests or 1,000 people hitting your website at exactly the same time, Lambda needs to run 1,000 different instances of that Lambda function to process the request.
So if you have 1,000, you need to invoke or need to have Lambda respond to 1,000 requests at the same time. So that means one instance of that Lambda function is running for each one of those requests.
Yeah.
Okay. So that's called scaling.
Yeah. So that's part of the thing of Lambda scales out rather than up. And so someone asked me earlier, well, what's the difference between that? And so a scale-up architecture is where you have some resources, and it's going to be an EC2 instance, a container, or something. And while it's live and running, you can add some more CPU, or even turning it off and turning it on again. You add some more CPU and add some more memory, and that sort of bounded box has some more oomph to do something.
So it's like horizontal scaling, but rather than vertical.
Well, this is vertical scaling, but Lambda acts as horizontal scaling. Instead of making a bigger thing vertically to add more resources, it just adds a duplicate copy.
Yes.
And so it's scaling that out, horizontal processing. Yes.
I like the analogy of like the vertical scaling is if you need more bandwidth to do something. Let's say you want to take it to like an analog world. You want to be transported to somewhere. So you might need a bicycle to transport yourself. But if you've got more people, you might then need a car and then a bus and so on and so forth. Whereas a Lambda version of that would be everyone gets their own bicycle.
I like it. Yes.
I like this one.
Yeah.
Okay. So what was the change that recently happened?
So the way that happened before is you could have then 3,000 of those parallel requests coming at the same time, and then an additional 500 per minute. So if you started off with 10,000, 3,000 would be allowed, and all the rest there would be a throttling going, no, sorry, Lambda can't handle that for you. You need to wait, and then the client would retry.
So they would get 3,000 straight away, and then every 1 minute after,
another allocation of 500. And that would eventually scale up. And that was shared between all functions in your account.
And that was before today?
Yeah, that was before today. And that was also in big regions. So big regions in Dublin and the US East one and US West one. In smaller regions, it wasn't 3,000, it was 500.
Right.
So that was a much lower level. So that would be 500 and then additional 500 per minute. But that's the old way.
That's the old way.
So now what's happened is we've unified that across all regions, that it's the same amount, and it's 1,000 every 10 seconds for every function.
Per function now.
Per function. So previously, if you had 10 functions in an account who were all busy doing something that may be associated with your API, they in effect were sharing that 3,000. Now they're not sharing anything, and it's 1,000 each. All your functions can scale independently, and instead of taking that 20 minutes to get up to 10,000 requests, it'll take 12 minutes. It'll take 90 seconds.
Okay, so what does that mean for me as a developer? What can I do with that extra scaling?
It's one less thing you actually need to worry about. That you're not having to plan this sort of 3,000 and then 500 every minute, and this whole having to sort of have something in your head or something to manage that shared concurrency with the whole account. That's just something more to manage. So now, literally, I would probably say, and I can't pick a figure out of my head, 95% of customers will just be able to see this as a benefit, and it's one less thing they need to worry about.
Yeah.
That's part of the whole Lambda and serverless thing, is we just sort of make these things better in the background, and like, oh, it's now faster, it's now better, and you wouldn't when you're doing your load testing, you're not now hitting up to that limits and going, oh dear, what would that do? So yeah,
cool. Sounds like a win all round then.
No, yeah, in fact, even if I had to take off my AWS hat, which is difficult to reinvent, I can't think many negative things for this. It's just faster scaling. It's the same across all regions. You don't need to remember different things. And yeah, just a big winner. So I mean, we're super excited to see how people are going to do this, and just another sort of thing off your chest that you don't have to worry about. And Lambda's going to scale even better.
Wonderful. Well, thanks very much.
Two other things quickly.
Yes.
Because that's all for synchronous workloads. We've actually also improved the Lambda scaling with SQS and with Kafka event sources. So that's also just scales better. It doesn't quite scale in the same way, but it's just going to drain those SQS queues or consume those messages much quicker. So that's part of the Lambda scaling story. Yeah, plenty of stuff on that as well. Too much to go into now. But yeah, just think of Lambda scaling as being improving in a few different ways this year.
Interesting. Perhaps we'll come back and do another video just on that.
Definitely. Absolutely.
Thanks, Julian.
Thanks, Ben.
Cheers.